So I want to talk about Fibonacci not being the greatest sequence of numbers ever, and hey, Fibonacci is flawed. So I'm going to talk about that, and I'm going to talk about one of my favorite sets of numbers, a few of them. The Fibonacci sequence, it's 1, 1, 2, 3, 5, 8, 13, and so on. You just add the last number to the number, and there's like two ones. And yeah. And it's found a lot in nature and stuff. If you took the Fibonacci sequence and like you get to the big numbers in it, and you take two numbers that are right next to each other, like you have this number and this number right here, and you take this one here that's slightly, the one that's bigger than this one, and you divide this one by this one, and you take the bigger one divided by the smaller one, and you will get like really close to the golden ratio, or phi. And it turns out with any set of numbers where you're doing this, it will have the same effect. Like if you take out that first one, it actually changes it or something. I'm not sure how. It's like 1, 2, 3. Wait, I don't know. It's been a while since I've seen it, but okay, it's been a few hours since I've seen the one that went over that one. But there was another one that was, they all did it, but there was one called the Lucas numbers. It's not the Lucas set or anything, the Lucas sequence, because it's just the Lucas numbers are a small part of they're a type of Lucas sequence or something. It's complicated, but when you take phi and like you square it, you'll get one number, the first number in the Lucas numbers. Then or no, you take phi 1.6 whatever, and the first number is 1 in the Lucas sequence, and then phi squared. You round it after that first one. You just round to the closest whole number, and you will get the numbers in the Lucas numbers in the correct order, and that's pretty cool. And then the Mandelbrot set is like, you can find the Fibonacci sequence inside of the Mandelbrot set. I can't remember exactly where. I remember looking at the pictures of it a couple of days ago. But I think that's just one small reason of why the Mandelbrot set is better, because if you get closer and closer to 1.4, which is the highest x equals this, and smallest point on the x-axis that is in the Mandelbrot set is 1/4, or something like that. And just the closer you get to that with your epsilon, or like any infinitesimal number, like the smaller you get, the more digits of pi that are shown in the reiterations of an equation that basically says take it times 1/4, or divide it by, you do something with it. I can't really remember what, and it's however many reiterations of the equation get it to 2. So DFVA.